We have to find tie-set matrix corresponding to this coupled circuit. Okay, if we want to find tie-set matrix for this network, first we have to draw the graph of this network. Now, how to draw a graph? If you have voltage sources, short circuit these voltage sources, and if you have current sources, open circuit current sources, and if you have any elements like RLC elements, represent with a short circuit line. Okay, this is the procedure to draw a graph. If you see here, there are two nodes. Okay, here we have one element and voltage source. Okay, let us take this as first branch. Similarly, current flowing through this branch is in this direction. So, okay, let us consider this one. This is node 1 and this is node 2. Between node 1 and 2, we have one inductor. Direction of current is downward here. Okay, this is node 1 here and this one is node 2. Now between node 1 and 2 there is one resistor connected in parallel. Okay, and direction of current is downward. Okay, like this. And similarly, one more branch is there between node 1 and 2, that is this one. Okay, voltage source connected in series with inductance. So I am representing like this. Current flowing through this one is upward. Okay, now let us consider this one as branch 1. Okay, now branch 2 here is, see, he has given current to this one is I2, so current flowing through this one would be I1, so I am considering this one as branch 2 and middle one is branch 3. Now if you see tie-set matrix, now what is tie-set matrix? Tie-set matrix is drawn between number of loops into branches as columns. Okay, rows is equal to number of loops, columns is equal to number of branches. If you see here, there are 3 branches, so B is equal to 3. Number of nodes is equal to 2. Now number of links L is equal to B minus N plus 1. So this is 3 minus 2 plus 1, which is equal to 2. So the tie-set graph, the tie-set matrix is 2 by 3 matrix. Okay, now consider two loops here. Okay, this branch 3 is nothing but in twig we have. There are two loops, that is 1 and 2. Okay, now this is loop 1, this is loop 2 versus branch 1, branch 2 and branch 3. Okay, now consider loop 1 here. Okay, this is 1, 2 and this one is 3. Now after marking these matrices, okay, now if you see here loop matrix is drawn in terms of voltage drop in a loop. Okay, now consider here direction of current like this. Okay, this is the direction of current. We have to consider in terms of loop direction always. Okay, similarly here direction of loop current is like this. Okay, in terms of length. Now if you see here, this is loop 1 and this one is loop 2. Now mark the values of this loop matrix. Okay, if loop current is in the same direction of branch currents, take it as +1, and if loop current is opposite to that of branch direction of currents, take it as -1. Okay, now if you see here in loop 1 we have only 1 and 3 branch, so loop 2 should be 0. Okay, and direction of current in with respect to branch 1 is same, so it is 1. Similarly, direction of loop current with respect to branch 2 is same, so this is also 1. So 101 is the first loop matrix we have. Okay, now consider second loop. Second loop we have only 2 and 3 branches, so loop 1 entry should be 0. Okay, Now consider here loop current direction, which is in clockwise. It is same as direction of current in branch 2. So it is plus 1. Similarly, now loop matrix is here opposite to that of branch current 3. So this is minus 1. So answer is option D. Two trans cars A and B 2 kilometer and 6 kilometer away from a 600 volts DC substation. Okay, each return 40 amperes and 20 amperes to the rails. Trans cars is nothing but supply taken from the trolley wire to the top track. Okay, that means it is called as trans car. Okay, which is nothing but in tappings. This is 40 amperes and 20 amperes for A and B. Okay, now he has given resistance of trolley wire is 0.25 and that of track is 0.03. Now what is total resistance here? 0.25 plus 0.03, which is equal to 0.28 ohm per kilometer. Now what is voltage at trans car A? That is what we have to find. Voltage across trans car A and trans car B. Okay, voltage across trans car A is equal to 600 minus drop in the line up to trans car A. Okay, that means what is the drop we have? If you see, current flowing to this line is 20 amperes. Now what is the current flowing through this line? 20 plus 40. Sum of entering current is equal to sum of leaving currents. KCL law. Okay, that means this is 60 into 0.28. Since this is ohm per kilometer, we have to multiply it by 2. So this is 566.4 volts. Similarly, voltage across trans car B is VA minus drop in the line, that is 20 into 4 kilometers line, 0.28 into 4, which is equal to 544 volts. Otherwise you can write this one as 600 minus drop in the lines, okay, which is of 6 kilometers. Okay, 60 into 0.28 into 2 minus 20 into 0.28 into 4. This is also is equal to 544 volts. Answer is option A.